Documenting the destruction of the Roman settlement of Puig Ciutat, a multi-method research program. Part 1. Objectives. The Roman settlement of Puig Ciutat is located 60 km north of the city of Barcelona. It occupies a high plain of around 5 hectares. It is protected by a cliff on its northern and western limits. The first excavations indicated a possible violent destruction of the site. It was suggested by abundant military weaponry and burnt areas. The project was centered on the eastern open field of the site. The main objectives were detecting thermal alterations, describing the depth variation of the bedrock, and describing the constructive features. The methods used were a magnetic survey, ground-penetrating radar, electromagnetic induction, and excavations. The main limitations were bad ground conditions, a systematic deep plowing, and a low contrast with the surrounding sediments. Part 2. Individual surveys. The result of the magnetometer survey show in black the negative contrast and in white the positive contrast values. The dipoles of random orientation were associated to possible metals. The metals that presented a higher interest were labeled. The areas of high contrast were delimited and associated to possible thermal alterations. 2 areas were associated to sediment accumulations. Other areas of interest were delimited but were not interpreted. The results of the magnetic susceptibility show in black the low and in white the high values. The high susceptibility areas were delimited. They could be explained by the action of fire on the sediments and by the presence of metals. The result of the electric conductivity show in black the low and in white the high conductivity values. Additional metals were identified. One area of low conductivity was delimited. It was associated to a higher density of constructive structures and possible collapsed areas. The other low conductivity areas were associated to the superficial bedrock. The results of the GPR survey show in white the low and in black the high reflectivity values. The evolution of the results with depths is shown in a sequence of slices of the 600 MHz data that goes from a depth of 20 to a depth of 80 centimeters. The sequence can be resumed using 3 intervals. The intervals are shown below on a vertical section of the data. The first interval shows the top of the level with constructive structures and the superficial bedrock. The second intervals show the main level where the constructive structures can be observed and the bedrock. The third interval was produced with the 200 MHz data. It shows constructive features with a different orientation, possibly related to a previous phase of occupation. It also shows extensive areas associated to a compacted or collapsed level. The excavations were decided based on the position of the defensive wall and on the areas of interest delimited by the interpretation of the geophysical data. They can be divided in 3 main areas. Area 1 shows the defensive wall, connected rooms, and a lower level with a different orientation. Area 2 shows one room with burnt and partially destructed wood beams. Area 3 shows the southern part of the defensive walls and connected rooms. Part 3. Conclusions. The constructive structures were mainly characterized by the GPR survey and the excavations. They show two possible phases of occupation. The GPR survey only partially described the structures. This was mainly due to the low contrast between the building material and the surrounding sediments. The structures affected by fire were identified and signaled in red. This delimited the main area of the destruction. The bedrock was detected by all methods and its variation in depth was characterized with GPR. Possible metals were located and labeled. They can correspond to military weaponry or to modern contamination. The main area of occupation was defined using the result of all methods. The occupation of the remaining open area cannot be discarded.